Okay. All right, and I'm gonna record this just so that I can post it so people can see it as well. Have you guys tried to look at the videos yet? Like, was my video posted yesterday easy to access? Did you guys try it at all?
Yeah.
It was easy?
Mm-hmm.
Okay, perfect. All right, so Gianna, you had a question on number 4. So I'm gonna kind of jump to that. Number 4 is saying, let's see, the scale factor is 6/11. So the first question is, what's the area, the ratio of the area? So we're going to square both sides. So you're right, you get 36/121. And then this is small because this is a smaller number, and this is the large. And the reason why I'm setting that up is because now I know that the area of a particular parallelogram is 40. So it'd be 40 over x. So now I'm going to multiply. So I'm going to do 36x equals, so I'm cross multiplying. I'm going to get 121 times 40. And then divide by 36. So x equals 134.4 centimeters squared. So the ratio would be 36/121. And then the area of the larger is going to be 134.4.
Do you think you could scoot it over a little bit?
Yes, I'm sorry.
It's okay.
I'm going to zoom everything in. I lose track of how much space I have. There you go.
So okay. You have to add the decimals. Add this 134.4. Okay, yeah. Oh.
That makes sense?
So with these, you always have to square it to get the ratio of the areas.
Yes, because the key is we're talking about areas. So if we're talking about the ratios, we square them and then we just stop. Talking about an actual area of a specific parallelogram, then we have to go forward and do the cross multiplying, setting up proportions, small is to large, as small as to large, and then solving for the missing.
Okay.
Okay, so I'm going to just kind of go through here and you guys can check to see that you guys did them correct. So scale factor is 3/5, so perimeter is going to be the same, 3/5. Ratio of areas is going to be that squared, so 9 and 25. If we look at number 2, we're doing the same thing, but the difference between number 1 and number 2 is that we've got 4/18. And before we do anything, we want to simplify this fraction. So I'm going to divide by 2 to get 2/9. So A is 2/9, B is 2/9. What do you guys think C is going to be?
You square both of them, right? You do this like I got 4/81.
Perfect. Okay, and then this one number 3 is going backwards. So this one tells us that our areas are these two. So 75/147. So the first thing I'm going to do is look to see if we can divide something out here. I feel like we can divide something out here. So let me see. Maybe.
Oh yeah, that one was kind of weird because I didn't know if you just leave it to 75 over.
Well, we're going to have to take the square root. And so I'm looking at these and these are not perfect squares. So that's why I think I have to divide something out. So I'm going to divide out, I'm guessing maybe a 3. So if I divide by 3, I'm going to get 25/147 divided by 3 is 49. So now see how those two are perfect squares? I got 25, 47, 49. So this and this, I'm going to get 5 and 7. And remember the scale factor and the ratio of perimeters are going to be the same. So these two answers are going to be the same, 5/7 and 5/7.
Okay. So you always have to do the square root of, okay.
Yeah, so we're going backwards since we're going from area to perimeter because we squared to get from perimeter to area. We're now going backwards and taking the square root.
Okay.
Okay. So we already went over 4. So let's go over 5. Let me move this up here. Actually, okay, so here is 5, 6, and 7. So remember that minor arcs are less than 180, major arcs are greater than 180, and semicircles equal 180. So major arcs would be like L, E, all the way to A. So that could be 1. We could do E, K to L going this way. E, K to L. E, K to L. You could have started at L and gone this way. We could have started at A and gone A, L, all the way to K. So there's lots of different ones. Oh no, am I doing, oh shoot, I'm doing major arcs. Ah.
Yeah, I was like, wait, sorry. I was like, what?
I just started thinking, yes, and then I realized, wait, I'm going too far. So I'm gonna move those down. So my thinking was the major arcs. So that's for number 6. I basically was just doing.
So is minor arcs just like the 2 letters, right?
Yes, correct.
Okay.
So it could be any 2 letters. So we could do E-K.
Yeah.
E-K. What's another one you think?
L-E? Would that be another?
L to E, sure.
Okay.
L-E. Another one could be L to A or
Oh,
A
yeah.
to K.
Oh, yeah.
So it's anything that is, and really this one, now that I think about it, we don't have a line here. So there's not really like a measurement here. So I would say
Yeah.
E to K or L to E would be the 2 that we would want to focus on.
So it has to have a line to.
Yeah, it's got to have a line. I didn't notice this one doesn't have a line. So we could do this one for the minor arc though. We could do L-A-K. And then L-E-K. And these always have to have, so a hint is the arcs and the semicircles have to have 3 letters. So like when you're taking your test, you're going to have multiple choice and you're going to be able to just pick which ones are semicircles. So I'll pick the ones that only have 2 letters.
For the minor arcs.
Yeah, yeah.
Okay.
Okay, so here's this one.
And that one's basically just adding like to find the V or the Y.
Yeah,
and the V.
yeah, and sometimes it's like almost nicer to just go, okay, well, let's find the missing ones first because at some point in time, we're going to use them.
Yeah.
So we could do that now. We could say, okay, if this is 180 here, then this one here must be 180 minus 75.
I got 105 for that.
105. Okay.
Yeah.
So that's 105 here. And then we could also do this one here. This is also 180. This one here is 180 minus 128. 180 minus 128. And I'm getting 52 for that one. So make it right. So now we can kind of look to see, well, the first one they asked was Y to V. So Y to V, we already said that was 105. V to Z, so V to Z, we just figured that one out. Z to Y, so okay, so now this one we're going all the way around here. So that'd be 52 plus 105. So 52 plus 105. So 52 plus 105, I'm getting 157.
Yeah, I got 157.
Okay, and then XZV, so X, Z all the way to V, I'm getting a 180 because that's a half circle. And then,
Oh.
Does that make sense?
I thought you do, for X, Z, and V, I thought you do, wait. I thought you do 128 plus 52 plus 105.
Well, if you did that, then you'd be going all the way around to Y.
Yeah.
See how you stop right here? So you could add these two together. You would just add 128 and 52. And that
Okay.
would be 180. I think this one is the one you're going to add 3 of them. Let's see. Y, we're going X this way, so 75, and all the way to V. So we're going to do 75, 128, and 52, or you could do 75 plus 180. So 75 plus 128 plus 52. So in that case, we'll get 52 plus 128 plus 75. So I'm getting 255.
Yeah.
Okay. All right, let's move to the back. Okay, so 13, 14, and basically the rest of the page here is all focusing on these formulas, and on the test you will see these formulas right above the section that you're going to use them for. So you do have them there to kind of look at, but I'm sure you guys will have your notes out as well to kind of refer to. So this is talking about circumference. Yeah, did you have a question?
What? Sorry, no, it's the loud thing in the.
Okay. All right, and then I just added here pi d just in case we do have the diameter, because I see 14 we do. So
Oh yeah.
this would be 2 pi r. So circumference equals 2 pi times your radius. We're allowed to multiply those two together, so we get 12 pi inches. So
Oh shoot, I forgot to write inches. Okay. Oh my.
So pi inches. And then this one here, because we have diameter, we don't have to double it. So it'd be circumference equals 16 pi millimeters. Pi millimeters.
Okay. So for 14, you're kind of like doing the reverse of it. Like you have to.
Yeah, well, you don't have to multiply it because it's not, what do I want to say? Like it's not, you don't have to double it because you don't have half. Like half of that is 8, but if you plug it into this, then 8 times 2 gives you 16. Well, we already had the diameter, so we didn't have to do anything to it. So that's why it's just 16 pi.
Okay. And for 15 and 16, those are kind of confusing. Like you have to you're trying to find the shaded, like the A and the B, right? Like the little.
Yeah, like you're trying to find the outside piece. Like basically, what is the distance from A to B? Or what is the distance from C to D to E all the way around? So this is where we're using that the arc formula. So that's this one right here. So arc length would be degree over 360 times your circumference, which is 2 pi r. So degree here is 60 degrees over 360 times 2 times pi times your radius, which is 24. So I would change this to 60 divided by 360 times, and I can multiply these two together to get 48 pi. And then the rest, and we're talking inches, the rest I would just plug right into the calculator. So I would literally do, let's see, I would do 60 divided by 360 equals, and then multiply that times 48, and I'm getting 8. Getting 8 pi inches. So 8.
Oh, you don't put inches squared. Oh my gosh.
So this one we don't put inches squared yet because we're just doing length. When we get down to number 17 onwards, anytime we see the word area is when we're going to square it. So area, 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 the last 3 sections.
Oh, okay, that makes more sense.
Okay. So this one, I know that this is 90 degrees here for number 16. And then this entire thing is going to be 360 minus the 90 degrees that we already know about.
Yeah.
So should be 270. That's the degree we're going to use. So I know some people on the quiz made a mistake of using 90 degrees here just because that's what you see. but that's not what we're looking for. We're looking for the length of all the rest of it. So kind of like the Pac-Man piece. So it'd be 2 over 360 times 2 pi, and your radius is 10. So I would multiply that together and get 270 over 360 times 20 pi. So 270 divided by 360 equals, and then times 20. And I'm getting 15 pi centimeters. Can you see that? There you go.
So are there going to be ones that are going to be like number 16 but are not going to have a 90 degrees? Or are they always going to be like that?
Are they going to be what?
Is there going to be ones on the test that are like
16?
Yeah, with
Yes.
like the 90?
Yes.
Is there going to be ones without the 90 though, and it's just like the 360 minus something else?
No, it'll usually have like what you need. Like this one here tells you that this is a 90-degree angle here. What you have to make sure you do is notice that this is the piece we're looking at, not the one with the 90 degrees. So it's to just see, like, that's why whenever you have like the dark piece, you want to kind of, that's why I put like the little squiggle line on here. Like this is what we're focusing on, not the 90 degrees. That helps me get to what degree this is going to be.
Okay.
Okay. All right, so moving on, this is area of a circle. So area is, I'll just put the formula here. The area of a circle is pi r squared. So area here is going to be radius squared is 11 squared times pi. And this one, since it's area, we would square the 11 to get 121 pi, and then we do feet squared.
It's kind of just quiet and very in all the I've been through so far.
Okay.
Yeah, I'm partially in one right now.
Okay, so if we look at this one.
What?
Sorry.
Yeah, when you leave, you can just stay.
How to find my Matt? Your volume's on, just to let you know.
Whoops.
What we got here? Okay. We got a good little crowd here today. I see we got Marion. Hi, Marion. I know you're probably not talking or your volume's off. Everybody's video's off, but I see some people on, so that's great. Okay, so then the last one here is area equals. So keep in mind that this is your diameter. So remember that we want the radius. So we have to half that to 7. So it's 7 squared times pi. 7 squared is not 14, so be careful. That's 49 pi meters squared. So 49 pi meters squared. Okay, so now I'm going into the sector. So this is finding the area. So it's very similar to like 15 and 16. It's just this one is you're doing instead of this last part being 2 pi r, we're now going to do the radius squared. We're going to use the area formula. So this one, 120, we're trying to find this area, 120 over 360 times pi radius squared. So I'm going to just move this around so that's easier to put in my calculator. So 12 squared is, what is that, 144? Times 12, 144 pi. And now I'm going to put all of that in the calculator. So I'm going to do 120 divided by 360 equals, and then I'm going to multiply that by 144. And I'm getting 48 pi inches squared.
Okay, so you square those. So any of the ones that say area, you square those, and then the ones that are the arc length, you have to
Yes.
Just put inches or whatever it is.
Yep. You got it.
And for number 20, I was kind of confused because
Okay.
I got it wrong on the quiz because I did like the little part instead of like the
Yes.
whole thing.
Yes.
But
Yes.
I figured out, so you have to do 300 minus 60, right?
You're close. 360 minus.
Or, yeah,
360
360 minus 60
Uh-huh.
to
Correct.
get
So
300,
yes. 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 And you are right.
which is the degrees.
Yep.
Okay.
That is this degree right here. All this is 360. Or no, because we take away. We do 300 here. Okay, and then times pi, and then radius is 6 squared. So I'm going to get 300 over 360 times 36 pi. I could probably simplify this easily as a fraction, but again, I've been using my calculator, so I might as well do the same thing for this one. So I'm going to do 300 divided by 360 equals, and then multiply that times 36 to get 30. So this is going to be 30 pi meters squared.
Okay, yeah. That was it's just weird because you have to figure out what the degrees is by like
Yes, so this one is very
solving it.
to like 16, where remember how 16 we had to find this degree here, this one right here,
Yeah.
because we had to subtract. So we had to do the same thing here because we've been given information that we don't really need. We actually want to use the other piece of information.
Oh yeah, they are really similar because you're just subtracting.
Right. The only thing that's different is that one of them you're using the circumference formula and the other one you're using area formula.
Mhm.
Okay, last two. So these are the ones that are like slivers or pieces that you're going to either have to take away or put together. So this one here, this one is where we're going to find the area of the entire piece of pizza. And we're going to take away the triangle so that we have just the crust.
Yeah.
Okay, so this one, the area of this entire piece is going to be 90 over 360 times pi r squared. So r is 8 squared and then pi. So I'm going to kind of write it all out and then I'll go back and simplify it. And then this is minus 1/2. So base and height, if that's 8, this has to be 8. So it's 8 times 8. So kind of looks crazy in here. So now all we have to do is just simplify what we got so far. So I'm first going to do this. This is 90 divided by 360 times 64, because 8 squared is 64. So
and then you have to half it. So are you breaking up half of it basically? Like you have to solve.
Well, I'll do like half of this. So yeah, I would do this together first, and then because you're going to end up with a pi on this side. So 90 divided by 360 equals, and then multiplying that by 64. So this side right here is 16 pi. And then I'm going to subtract what this is right here. So this is 8 times 8, which is 64. And when I divide that by 2, I get 32. So I'm going to getting 32, and all of that is going to be feet squared.
Okay.
So what's kind of nice about this is that you're not really having to do the subtraction. You just leave it in there because you've got to deal with the pi. Now, if we wanted to, we could do 16 times pi minus 32 and get a decimal answer. But because it says leave in terms of pi, we're just going to leave it as is.
Okay. Yeah, those make more sense now because I was like confused.
Good. Okay, so this one, we're looking for the shaded region. So let's see here. I'm trying to think of what we did. Did we do a box on the area of that, and then we took out the circle? That's what we did. Finding the.
So is it square minus circle?
Uh-huh.
Is that like
minus circle gives us the shaded pieces. Visual here. Okay, so square is 18 times 18 because it's base times height. Minus pi. So this is kind of a trick, radius squared. So we have to first find our radius. So this is going all the way across. This is 18 inches. So if that's all the way across 18 inches, so is this right here. But that's not our radius, that's our diameter. So if our diameter is 18, half of 18, which is 9, would be our radius.
Yeah.
So let's see what we got here then. We've got 18 times 18. We're going to get 324 minus 81 pi. So 324 minus 81 pi, and all of that is inches squared.
So something I'm also noticing about like those are like, so you know how you solve it with like for 21 you put the 90 over 360 times 8 squared and then the pi. You kind of like write it how you see it, like whatever you get as like that the answer was 16 pi, you write it in the same order as like the equation.
Correct. Yes.
Okay.
So you're simplifying the left side and you write that first. Then you simplify the right side and you write that next. So that's why the pi on this one is on the right-hand side, because it has to do with this circle. So you want to do the order that you have written down. So I try to do the visual first and then do the numbers that match up with, here's the area of the triangle minus the area of the circle gives you the area of the shaded pieces.
Yeah.
Okay. Cool.
Thank you. That helped a lot.
Yeah, no problem. I'm going to, let's see, I'm going to go back here and do, let's see, where is it? Stop share. I don't need to share everything, and then I could.